All right, this video is going to go over pages 32 through 34 in your packet. So we're talking about refraction and critical angle. So it says a beam of light strikes a pane of glass at an angle of incidence of 60 degrees. So this is your theta I. Okay, if the angle of refraction is 35 degrees, so this is theta R. Okay, find the index of refraction of the glass. Okay, so remember, Ni is the index refraction of your incoming or incident ray. This one is kind of vague, but on a test we would normally tell you if it's talking about hitting the glass, that means your original index was air. Okay, so that would be air, and that would be 1.0003. Again, that's just using that box on the very last page of your packet to determine your index of refraction for air. Okay, so that means you don't know what glass it is. So I've got a lot of students that are looking on that box and are saying, well, which glass are we using? Well, we don't know. That means you're actually you're looking for what is my NR. Okay, so if you have two angles and you have two ends, this is when we're going to use Snell's law. So this is the Ni sine of theta I equals Nr sine of theta R. Okay, so Ni is 1.0003. Sine of your original angle, so that was 60, equals Nr, we don't know, times sine of theta R. Okay, so that would be 35. Again, make sure you're in degree mode on this one. So I would solve the left side and then divide both sides by sine of 35. Okay, you don't need to do inverse sine, anything like that. Okay, just divide both sides by sine of 35 and you get Nr with a value of 1.51. And there's no units for Nr, it's basically just a ratio or index, so you're good there. Okay, number 2, a diver shines a flashlight upward from beneath the water at 31-degree angle. So this is your incoming, your original, so this is theta I. Okay, and it's talking about water. Okay, so this would be your Ni. Okay, your original index, we gave you that right here, water. Okay, at what angle does the light leave the water? So that means you're leaving water and going into air. So air is going to be your Nr, and that is 1.0003. So it says, what is the angle it's going to leave at? So that means you're looking for theta R. What is your new refracted angle? So you use the same equation. So Ni is 1.33 times sine of your original angle, which is 31, equals Nr, which is now 1.0003, times sine of theta R. So again, this is what we're looking for right here. So what I would do is I would solve the left side and then divide both sides by 1.0003, and that gives you 0.685 equals sine of theta R. So remember, I want the theta R, I got to get that sine off, so I'm going to bring that sine over, and when you bring it over, it becomes inverse sine, so sine of the -1, and go ahead and put that 0.685 in there. Okay, and that's going to equal your theta R. Okay, so if you type it in correctly, we should get a critical angle or a refracted angle of 43.24 degrees. Okay, 3, a beam of light enters an unknown liquid from air. Okay, so that means we're talking about there's your Ni, okay, air. Okay, at an angle of incidence of 30 degrees, so there's theta I. Okay, and refracted to 18 degrees, so that is your new angle, so theta R. So that means we're looking for the index of refraction for your refracted light. So that means you're looking for Nr. Okay, so Ni is going to be for air, so that's 1.0003 times sine of your original angle, which is 30, equals Nr, we don't know, times sine of your new angle, which is 18. Okay, so multiply, get the left side answer, divide both sides by sine of 18, and you get a refractive index of 1.62. Okay, 4, what is the angle of refraction of a beam of light that enters the surface of a lake at an angle of 50 degrees? Okay, incidence, okay, so this is your theta I. Okay, you're going, it enters the lake, so that means you came from air. Okay, so that means your Ni is going to be air, okay, which is going to be the 1.0003. Okay, and it says, what is the angle of refraction? So that means you're looking for theta R. Okay, so you have Ni. Okay, you have your original angle, you have your Nr right here, you're now in water, so that's your new one. Okay, so we're just going to plug in. So Ni, 1.0003 times sine of your original angle, which is 50, equals Nr, which is 1.33, times sine of your angle, which we don't know, that's what we're looking for, So I would multiply that, get the left side, and I would divide both sides by 1.33, and then take the inverse sine of that, and then you get a theta r of 35.17 degrees. Okay, moving on to the next one, number 5, it says the speed of light in a certain type of glass is 1.91 times 10 to the 8 meters per second, so this is your velocity. What is the index of refraction of that glass? That means you're looking for n. Okay, so this is where we could do n equals c over v. Okay, so n, we don't know. C would be the speed of light in a perfect scenario, that is in space or a vacuum. 3 times 10 to the 8th divided by whatever your new velocity is, 1.91 times 10 to the 8th. And you get a refractive index of 1.57. Okay, 6 here, it says light enters a piece of glass from water at a 38-degree angle. Okay, so this is your theta I right here. Okay, so it says find the angle of light it makes when traveling into glass. That means we're looking for this angle right here, so that is your theta r, that's our question mark. Okay, now we do know our Ni, so our Ni is water, which is 1.33. And our Nr is going to be glass, which is going to be 1.55. Okay, so we're going to do Ni, 1.33 times sine of the original angle, which is 38, equals Nr, which is 1.55, times sine of theta r, which we don't know. So solve the left side, divide both sides by 1.55, and then just inverse sine that. And you get an angle of 31.87 degrees. Number 7, the index of refraction of rock salt is 1.66, so this is your N. Okay, what is the critical angle for light that is trying to go from inside the rock to air? Okay, so I did give you an N there, but we just figured out which one was which. Okay, you're going from rock to the air. Okay, so that means rock salt is my Ni. Okay, air would be my Nr. Okay, so on this one, we're looking for critical angle, so this is theta C. So remember we gave this equation right here, theta C equals inverse sine of -1 over, so of Nr over Ni. So we're just going to plug in, so inverse sine, Nr over Ni, air is 1.0003, and then your Ni is 1.66. So again, remember your trick for this is the big number always goes on bottom, otherwise you're going to get an error symbol in your calculator. So make sure you're in degree mode again. Okay, and you should get a value of 37.06 degrees. Okay, the critical angle for total internal reflection in lucite is 41 degrees. Find lucite's index of refraction. So you see how it didn't really mention any other material. So that means the other one is air. Okay, so remember, critical angle is always more dense to less. Okay, so that means we have to be going from lucite, okay, to 41 degrees. To air. Okay, so in this case, what we're doing is we know our critical angle. Okay, we're basically using this equation right here. Critical angle equals inverse sine of -1 of Nr over Ni. Now in this case, I do have a critical angle, so I'm just looking for that. So what you can do is you can actually bring this sine back over. So this is basically saying normal sine of theta C equals Nr over Ni. Okay, so that's basically all we did. We just rearranged that equation to help us clean it up a little bit. So sine of our angle, which is 41, equals Nr over Ni. Okay, so that means we have to be going from more dense to less dense. So that means lucite is our Ni. Okay, and then Nr has to be the air that you're going to. So remember, Ni is the one you come in with. Nr is the one you leave with. So that means you have to be going to air, which is 1.0003. Okay, so that's where you really need to make sure you know which one's Ni and which one's Nr, because that will definitely give you two different answers. Okay, so again, Ni is always the one you come in with, the incoming one, and it has to be the more dense one in this case. Okay, and then the Nr is the one you leave with. So again, you can switch these. Ni goes on the left side. When you bring sine of 41 over, don't do any inverse sine, stuff like that. So it's just 1.0003 divided by sine of 41. Okay, so my Ni is going to be 1.52. Okay, 9, what is the critical angle for light passing from a diamond to air, so air is 1.0003. Okay, so I'm going from a diamond, so that is my NI, and this is my NR. Okay, so we're going to find our critical angle, inverse sine of NR over NI, so 1.0003 over 2.42. And we get an angle of 24.42 degrees. 10, what is the critical angle for light passing from crown glass into water? So crown, if you look on that box, so crown glass is 1.52. So you're going from crown glass, so that's your NI, to water. Okay, so that's your NR, that's 1.33. Okay, so you're going to do critical angle equals inverse sine of 1.33 over 1.52. And you get 61.04 degrees. So just a lot of practice here on this stuff. 11, what is the critical angle for the following if the exterior surface is air? Okay, so that means you have to be going to air, okay, because air is going to be less dense. Okay, so that's going to be your NR, which is 1.0003. Okay, your diamond is going to be your NI. Okay, that is going to be 2.42. So inverse sine of 1.0003 over 2.42. That gives you an angle of 24.42 degrees. Okay, water in this case, so your NI is going to be 1.33. So we're going to do inverse sine of 1.0003 over water, 1.33. Get 48.77 degrees. Okay, ethyl alcohol. Okay, so ethyl alcohol, that's on your list. Okay, that is 1.36, so NI 1.36. So inverse sine of 1.0003 divided by 1.36, and we get 47.35 degrees. Okay, 12, the critical angle for a certain surface is 38 degrees, so there's your critical angle. Okay, when it's surrounded by air, what is the index of refraction? Okay, remember you're going from more dense to less dense, so you're definitely going to be going to the air, so this is NR, 1.0003. What is the index of refraction of the substance? So that means you're looking for NI. Okay, so remember we said you could say sine of your critical angle equals NR over NI. Okay, so that's if you just bring that sign back over from the original equation. So sine of 38 equals NR, okay, which we know that is 1.003 over NI, which we don't know. Okay, so just switch these two. So 1.0003 divided by sine of 38. Okay, and you get an NI, or a refractive index, or original index, of 1.62. What is the critical angle for flint glass immersed in ethyl alcohol? So we got to figure out which one are we going to. Okay, so flint glass, if you look it up on that box, okay, so flint glass would be 1.61. Okay, ethyl alcohol is 1.36. So again, remember these numbers basically tell you how dense it is, and critical angle is always more to less. Okay, so that means you have to be going from a more to a less. So that means you have to be going from flint glass. Okay, so that is your NI. Oops, messed up there. NI, and that means ethyl alcohol is your NR. Okay, so critical angle equals inverse sine of NR over NI, so 1.36 over 1.61. And you get a critical angle of 57.64 degrees. That'll end that one.